Hey guys, for the next 3 days, we're all going to be doing the same thing. So we are going to do a little Algebra 1 review, and we did this first semester as well. The purpose of it is most of you who pass this are going to be moving into geometry next year, and right away at the beginning, it's expected that you remember your linear algebra, but we've been working on exponential algebra, so we're just going to take a little break for 3 days, and we're going to solve equations, because what's going to happen in geometry, and you don't need to put this on your note sheet. Actually, our objective is going to be solving what we call linear equations. And you've done this before, so we just have to bring it back to the forefront because it's been since 8th grade that you took linear algebra, and then it's going to be in 10th grade when you take geometry. So we're going to kind of try to bridge that gap today. So put the date on here. It should be April 8th today. So let's do 408, please. And I'm going to collect the 3 notes and the 3 worksheets one day at a time. So what you'll do tomorrow when you come into class is you're going to staple the notes in the worksheet together, and that's going to come in as one chunk. And I won't take any of it late. So it'll just be 3 assignments, 3 days in a row, and then a small quiz at the end. So first thing, our goal today is just going to be how do we solve when the variable is just on one side? And let's do how do I solve equations with the variable on one side? So variable on one side, you might have to run into the next part of here, on one side and parentheses. So we're going to throw both of those in. What's going to happen, and if I write in green, don't write it on your note sheet, but in geometry, you're going to be working a lot with different figures and lines, and don't write this down. There might be a trapezoid looking like this and all this good stuff, and you're going to have theorems that tell you how angles are related. So it might say this is 2x plus 10 and this is 3x minus 5, and you're going to get a theorem that says that these angles that are across from each other, like on a pair of scissors, are equal. So you'll set those equal and solve. Well, it doesn't do any good to know the geometry theorem if you don't know how to solve the equation that results from it. Same thing here. You're going to have a little theorem that's going to tell you that all of these angles up here add up to 360 for a trapezoid. So you're going to have to add all those up and solve it. So there's a lot of solving equations in your geometry class, and it's been a while, so we're just going to work on that for a couple days and have just a mini test, all of us on the same day doing the same thing. So usually what I'll do here each day is we'll do 3 or 4 examples, and then you'll just go work. You'll be able to raise your hand and have somebody correct them as you're working so you know if you're doing them right. I might even post a key somewhere too, but for example, all right, so you've already solved in here what I would call 2-step equations because we had some stuff where we had to figure out what the solutions were. So going way back to when you first started. Now we're going to have ones much harder than this, but let's go way back to when you first started solving. You're trying to figure out what values for x, when you put them in, will result in you getting a 5 out. Well, we do what are called inverse operations. So basically, our goal is to attack x. We need to strip off everything that's in the way. It's kind of like, taking clothes off in a sense, because you take off if you consider x like your body, you need to take off the outermost layer first, and you do it in the opposite manner of which you put it on. If you zip your boot up to put it on, you unzip it to take it off. And that's exactly what we're going to do here, is strip these number layers off until x is all alone. So 2 is attached to x. It's the -1 that's kind of out there. So you've been taught that you do the opposite, which is to add 1 to both sides. And sometimes in middle school they'll have you put this down, kind of like a balancing scale, that you have to do the same thing to the left as you do to the right. And I think that's a good idea to put that on there. It helps you from doing it to the same side twice. So if I add 1 on the left, I'm down to 2x, and if I add 1 on the right, I'm at 6. And then to undo 2 times x, I need to divide by 2. So I do the inverse operation, or the opposite of multiplication is division. And I end up at the bottom here with an x is equal to 3. And I know that's easy for you, but I just wanted to get the general basic idea of it down before I bump up the difficulty in the next few days. So I know my answer is right because they're easy to check. When you take your little test on this in 3 days, if you're done early, you should really just go back, get a calculator, and plug all your answers in and see, does 2 times 3 minus 1 equal 5? And it does, obviously. So I know that my answer is correct. Now, we're going to bump the difficulty up here quite a bit, even right away on today's, because I know without parentheses and without negatives, you should be really rock solid. So what I'm going to do is 3 examples where I have lots of negatives and lots of parentheses. And that's it today. I'm going to keep the variable, though, on one side of the equation, so we won't have to worry about that. And I'm only going to have one set of parentheses today. So example number 1, that last one was a review example. So the way your homework is going to work for this section is you're going to get 5 points per notes, 5 for the worksheet, 5 for the notes, 5 for the worksheet, 5 for notes, 5 for worksheet. There'll be 30 points in my gradebook for notes and worksheet, and then there'll be a small test. So to get full credit for the notes, you just need to write down everything I do. So we are going to solve -5 times -3x minus 1 is equal to 35. Now the reason this is not an exponential algebra problem is for something to be considered exponential, the degree has to be 2 or greater, and this is to the first degree right here, this x, so we actually call this linear algebra. So let's go solve. In order for me to attack that x, it's stuck inside some parentheses, so I need to pop it out. You've learned that to do that, we do hippity-hoppity, distributive property. So I'm going to hop that -5 in, and I'm going to keep in mind that a negative times a negative is a positive. So I've got -5 times -3 giving me a positive 15x. I have a -5 on the second hop times a -1 giving me a +5, and that equals 35. I now want you to circle the x, please, and I'm going to require that on your worksheet as well. Go circle what you're solving for. You need to strip off those 2 layers over there with the x, the 5 and the 15. The opposite of adding 5 is to subtract 5, and we do it to both sides. So we're going to subtract 5 from both sides. And we get 15x left on the left, and then we get 30 left on the right. And as long as we do the same thing to both sides, it stays completely in balance. The opposite of multiplying by 15 is to divide by 15. 15 divided by 15 is 1, so those cancel. And I get a nice x is equal to 2. So the only number in the world that I can plug up here in for x and have the whole left-hand side poop out a 35 would be the number 2. And you could check it on your calculator if you like, and it would certainly work. So that's number 1. All right. We're only going to do 2 more. Again, I'm going to try to keep the notes about 10 or 15 minutes per day, and you should be able to finish the worksheets in class, and it'll be nice and easy. Example number 2. Let's put that in a box. We are going to do 6 times 4 plus 2x is equal to, and let's make it equal to 60. Again, our goal is to attack that x, and immediately it's stuck in those parentheses, so we're going to hop this in. 6 times 4 is 24. 6 times 2x is a 12x. And I need to figure out what will make that equal 60. So now I have to do the same thing to both sides. Now again, go circle that x. My goal is to attack x and strip off all the layers. The outermost layer needs to be removed first. That's this 24. and I want to get rid of it. And it's a positive 24 being added. So for me to get rid of it, I need to subtract 24. 24 minus 24 is 0, and it'll be gone. Whatever I do to the left, I have to do to the right. On the left, the 24s are gone, and I've got 12x is equal to 60 minus 24. Shouldn't need to take out a calculator, is 36. And again, I'm trying to solve for x. Now it's 12 times x. It's not 12 plus, so I don't subtract. The opposite of multiplication, which is really what that is division. So I divide by 12. I divide by 12. The reason that works is 12 divided by 12 cancels, giving me a 1. And I get x is equal to 36 divided by 12 is 3. So I have found the one number in the world that, go draw an arrow, when I plug it in right here will cause the left side to poop out a 60. Watch. Let's go check it just so you trust yourself. If I do 4 plus 2 times the answer I got, which is a 3, that would be 4 plus 6, which is 10. And then 6 times 10 is 60. So it works perfectly. It's lovely stuff. Good rock solid math. And there is a ton of this type of math in your geometry class next year. So that's why we're just going to take a little breather from exponential math for a bit. We'll go back to it on Monday. So for number 3, we have a negative 7 times negative 4 minus x is equal to 7. And again, I'm trying to attack x. It's trapped in a set of parentheses, so I'm going to distribute the negative in. On the first hop, a negative times a negative will give me a positive 28. I'm going to hop this into the next one. A negative times a positive, and it's always good to stick a little 1 in front of that x so you understand that there is a number there and it's a 1. A negative 7 times a negative 1x gives me a positive 7x, and that'll equal 7. Now again, I'm trying to solve this for x. I need to get rid of the farthest away layer first, which is that 28. That 28 is positive and it's being added, and the opposite of addition is subtraction. And so I need to subtract that 28 to get it off of the left-hand side. Also have to do it to the right, and if you want to draw your little line down there, you certainly can. I normally don't do that, but I know they teach that middle school a lot, and I kind of like it. So then I have a 7x left on the left-hand side. 7 take away 28. You kind of think of temperature. It's 7 degrees. Goes down 28. It's going to be negative 21. And again, the opposite of multiplying by 7 is to divide by 7. So I'll strip off another layer by doing that. And I end up getting x is equal to, because these 7's cancel, x is equal to a nice negative 3. And again, it's very checkable. If I were to go plug that in, it will work. So our task now is the substitute teacher, or Mrs. Dutzman or Mr. Dorholt, will pass out worksheet number 1. And this worksheet is due tomorrow. It won't be accepted late, so you're just going to turn in what you have done on it. You should have the whole thing done if you're working in class, and they'll get corrected. So you get a point for problem correct. So make sure, if you want to get it right, you might want to make sure you have the substitute or one of the assistants check yours. All right, we will do 2 of them. Actually, I think we'll just do 1 of them together. We'll do on worksheet number 1 once it gets passed out. So maybe we'll do number 7 together, and you can just pause this video until everybody has a worksheet and everybody's ready to go. So pause the video and then replay it, and we'll go do number 7 on worksheet number 1 together. All right, so number 7 on worksheet number 1. Our goal is to solve for x, and let's begin. Calculators are allowed, but they will slow you up a little bit. So let's go take a look. I need to attack x. It's stuck in parentheses, so I do 7 times 10 is 70. I do 7 times a minus 3. That is a negative 3, so make sure you understand that when you have this positive 7 times a minus 3, you're going to get a negative. One of each makes a negative, 2 of the same make a positive. So I'm going to have a minus 21x is equal to 70. In order for me to solve this, you might say, oh, it's subtraction, I add. Well, this is actually a positive 70 right here. So if I add, I'm going to be up to 140. My goal is to get rid of it. So I actually do need to subtract that 70 off. And this one's kind of weird because I end up getting, don't forget to bring that sign down with you, it's not 21x, it's negative 21x, is equal to 0. The opposite of multiplying by negative 21 is to divide by negative 21. 0 divided by anything is just 0. Now this one could have been done with some common sense, so they'll put a little happy face in there, yay. Because obviously if something multiplies to equal 70, it's going to have to be that 7 times 10 in there. But you'll notice if I put a 0 in, I'll get 10 minus 3 times 0, which is just 10. And 7 times 10 is 70, so it works out spectacularly. I like it a lot. So your goal is to do worksheet number 1. That's your assignment. And then there's also an extra credit number 1. So there's actually going to be 3 extra credits with each of these as well. So just so you understand how, because we haven't been running the class like this, it's been self-paced. It's no longer self-paced for about the next 3 to 4 days, depending on how long it takes me to get through this. Tomorrow when you're going to come in, you're going to turn in the notes for 5 that you just took here. You can't get those wrong unless you're just sitting there. You're going to turn in the worksheet. And actually, I said it was for 5, but that's going to be for 10 because those will get corrected. Everyone's got 1 right now. So I'll have my proctor correct those for, or even the substitute kin if she or he is bored. A worksheet for 10, and then there's also an extra credit option. I'm not sure how many points I'll give you for each of those. The extra credit options are located on the back cart. There's 3 stacks, 1 for each day. So when you finish this, those of you who work really fast, when you finish this worksheet number 1, go ahead and grab extra credit number 1 as well. All right, you have a good one. You have a good about 40 minutes to work. Definitely plenty of time to get both the worksheet and probably the extra credit as well. So peace out, Girl Scout.